So what's up at the top, this is the standard equation of a circle. Notice that in the standard form it has h and k, like we talked about with transformations, but it doesn't have an a value. We have just a coefficient of 1 in front of both of these sets of parentheses. The center is at hk. Notice in the equation it says x minus h, but when I'm talking about the center of the circle, it's just a positive h. When we are finding h, you would take whatever's inside the parentheses and set it equal to 0, and then you would solve that for x, and that's why our h value becomes a positive in the center of the circle right here, but inside the equation it says minus. Does that make sense? Same thing happens with the y and the k. It says y minus k inside the parentheses, but you would set that equal to 0 to find the actual k value for the center of the circle. So when we see h and k inside the equation, it's always going to have the opposite sign of where it's actually located on the graph. And then for the radius, in the equation we have r squared, so I would need to take the square root of that to find r. So far, so good? We're going to graph a couple practice circles, and then we're going to start talking about how to find the equations for circles. So if you've got graph paper, pull that out. If not, see if you can borrow some from a neighbor. I only have a handful of pieces left, so hopefully some people have started to get their hands on some graph paper. This is all I have left, but I'm willing to make this available. All right. Anybody else need graph paper? Okay. Again, that's all I got, so do with it as you will. We're going to graph 3 circles. If there's any way possible, if you don't already have graph paper, to get some over the weekend, definitely do that, because we're going to be doing more graphing next week. And I can already tell from my graph paper supply that I'm going to run out real quick. All right. So we are going to graph each of these 3. I'm going to do them on separate graphs each time, just so I keep things really clear. For this first one, circle A, I need to know the center. Where would the center of this circle be? 3, 1. Take each of the parentheses, set them equal to 0, so I'd have to add 3 to both sides and add 1 to both sides to get the actual value. So I'm going to go plot that point. 3, 1. There's the center. What is the radius for this circle? 4. Because we would take the square root of 16, and that's how we get this. What does a radius of a circle do, or what does it mean? What's it describing to us? Distance from the center to the edge of the circle, yes. And that's the distance from the center to any point that's on the edge, right? I just need to get a couple points here so that I can sketch in the basic shape. So if I start at the center and I move 4 units to the right, that would be a point on my circle, because that's 4 units away from the center, right? I can do the same thing going to the left. 4 units to the left would be on my circle. Are there any other points that I could go on here that would be easy for me to plot so that I can sketch this out?
Up and down.
Up and down. So I'm going to go up 4, 1, 2, 3, 4, and down 4. don't draw a square. Remember, these are your reference points to draw a circle. Don't grab a straight edge. I'm not grading your art abilities, so if your circle isn't a perfect circle, that's fine, but it should look as much like a circle as you are able to make it. Mine kind of has a weird egg shape to it, but I did my best. And this is my circle A. You guys okay with that process? So when I look at the next one for circle B, where's that center going to be? 0, -3. There are no parentheses, so H would be 0 because it didn't move left or right at all. And my Y value for that ordered pair would be -3. So a center of 0, -3. I'm going to go and plot that right here. And what's the radius here? 3. Again, we do the square root of whatever comes after the equal sign to get our radius. So from that center, I'm going to count out in all 4 directions so that I can get my reference points to sketch in my circle. 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. There we go. And then do your best to make it look like a circle. You don't need to pull out a compass and use that for these. We're doing analytic geometry, which means we're going to have reference sketches, but then we're going to be mainly doing algebra with things. You guys okay with that so far? Part C is almost in standard form, but not quite. What's different about C than the other two? Has coefficients. Standard form does not have coefficients out in front, so I need to get rid of those 2's. How can I get rid of the 2's? Divide by 2. I divide every single term by 2. So here, that makes my coefficients cancel out. X minus 4 squared plus y plus 3 squared would be equal to 4. Now it's in standard form, and now I can identify the center and the radius. Where's the center of this circle at? 4, -3. And what's the radius? 2. Square root of 4 gives me this. So I'm going to plot a point at 4, -3. I'm going to go out 2 in all 4 directions so that I can sketch my circle in here. And this is my circle C. I should have marked my circle B. Let me go back and label it. There we go. So we label them based on where the center is. It's really only an issue if you're going to have lots of pictures on one single graph, then I would definitely need you to label it. If you have an individual picture for each graph, then you don't have to label it for me. All right. We good so far? Awesome. Please let me know if you guys have any questions or if I lose you at any point. Do not write all this down. Grab your phones, take a picture. Do not take the time right now to write all this down. If you want to later transcribe it into your notes, so be it. I want you to have these directions up and visible next to you while we do the next several problems. Looks like a lot of steps and it sounds very complicated. When we actually do this, it's not going to feel as confusing. But I do want you to have some steps to refer back to when you're doing these on your own at home, okay? So the first thing that we're going to do, we're going to be completing the square to put things into standard form. Welcome, Rian. You can pick an open spot, and I'll get you your test. All right. We're going to set these equations equal to our constant, not to 0. I want it equal to the constant. Then we're going to group our x's and our y's together. If there's a coefficient on the x squared or on the y squared, you've got to pull that out to the front. We're going to create a perfect square trinomial. We completed the square in the last unit. It's going to be the same exact process. So we're going to make a perfect square trinomial. If we had to pull a coefficient out to the front, we're going to have to multiply whatever we added to make it a perfect square trinomial by that. And then we would add it to both sides. I want to demonstrate what this looks like. Because again, written out in words, it sounds very long and complicated. We've done almost all of these steps. Do I have a constant that I need to move over to the right-hand side? Nope. This is my only constant here. If there was another constant, I'd need to move it. I want to group my x's and my y's together. So I see I have a 3x squared and a minus 12x. So I'm going to put those side by side. 3x squared minus 12x. I'm going to group my y's side by side. Plus 3y squared plus 18y equals 0. Do we have a coefficient in front of the x squared? Yes. I've got to kick that out to the front of these parentheses. It has to be just an x squared. We're going to kick that 3 up to the front. So 3, and that would leave me with x squared minus 4x. We're going to turn this into a perfect square trinomial, so I'm going to add something to this. Bring down my plus. We're going to group those y's. Is there a coefficient in front of the y squared? Got to kick that out to the front. So I have to take the 3 out of both of these. That'll come out here. And then I have y squared plus 6y. The goal is to turn this into a perfect square trinomial, so I'm going to be adding something to that. And then over on the right I have 0 plus, and I've got 2 blank lines here. Because the rules for algebra say if I do it to one side, I have to do it to the other side. Right now, if you ignore the blank lines that don't have anything on them, this is exactly the same as what I was given. I've factored some things out, but if I redistribute them, I haven't changed my equation at all. It looks a little different, but it has the exact same value. You guys agree? Okay. Once I put something on those lines, I will have introduced something new to the equation. And so if I do something on one side, I've got to do the equal thing on the other side. Do you guys remember when we completed the square, we took our b term, and what did we do to it? Divided by 2, and then squared it. So this would be negative 2 squared, which would give me what? 4. So I'm going to put a 4 right here. I didn't only introduce a 4 to this equation, though, because it's inside these parentheses. I would have to distribute to figure out how much I actually added, right? Because originally it's a 3x squared and a minus 12x. What did I actually add to this equation? I actually added 12. So over here on this other line, I had a 3 out in front. We added a 4. You could put a 12 there, but for this first example, I'm going to be really clear about why it's a 12. You guys okay with that so far? I have the product of my coefficient and what I added to make it a perfect square trinomial. For the y's, we need to make this a perfect square trinomial as well. So I'm going to take 6, I'm going to cut it in half, and I'm going to square it, which would give me what? 9. So did I only add 9?
Added 27.
I added 27. Why?
Because you multiply it by 3.
Multiply it by that 3 out in front. So I have 3, thank you, sir, times 9. All right. I've got that 3 out in front. I want to factor each of these perfect square trinomials. This first one with the x's that I have in blue multiplies to positive 4, adds to negative 4. Negative 2. So this is x minus 2 squared, right? Because it'd be negative 2 and another negative 2. Plus 3, and then I need to do that over here. Multiplies to 9, adds to 6. 3 and 3. So this is y plus 3 squared. Back here, I need to combine everything together. So I have 0 plus 12 plus 27. 12 plus 27 gives me what? 39. So this is equal to 39. Do you remember that graphing problem that we did last, part C? How it had those coefficients out in front and I said that wasn't in standard form yet? I need this in standard form. What should I do to it? Divide every term by 3. That will put it into standard form for me. So I have x minus 2 squared plus y plus 3 squared equals what? 13. Now that my equation is in standard form, I can answer the question. It said to find the center and the radius. Where would the center of this circle be located? 2, negative 3. And the radius? Square root of 13. Beautiful. I had somebody ask me earlier how you would graph that. Square root of 13, I don't expect you guys to memorize that or to do it in your head. If something like this showed up on a homework, grab your calculator, figure about how far that is. On a test, I'm not going to ask you to approximate something like that. If I'm asking you to graph it for me on a test, it's going to be something where you can find the square root of it. Okay? Ready to practice another one? All right. Do I have a constant? What is my constant? 16. So I need to subtract 16 from both sides. Constant has to go off by itself. I'm going to group my x's and my y's at the same time so that I've got them together. Do I have a coefficient that I need to take out? Nope. So I've got x squared plus 4x plus something. And then plus, I have y squared plus 6y plus something is equal to negative 16. Since I am introducing 2 new things into my equation, I'm going to have to do the same on the other side to keep it balanced. So I would do 4 divided by 2 and then square it. So what goes right here? 4. Do I have to do any fancy multiplication?
No.
Why not?
There's no coefficient.
There's no coefficient on the x squared, so I didn't have to kick anything out to the front. What about with the y's? What are we going to have here? 9. Do I have a coefficient here I need to worry about? Nope. All right. So talk to me about how the x's are going to factor. X plus 2 squared plus, what about my y's? Y plus 3 squared is equal to -3. So where's my center? -2, -3. What's my radius? Is that a problem?
Yes.
Why not?
3i.
Yeah, that's going to be square root of 3i. Can we graph imaginary things? Not on any plane I've introduced you to yet or that you know from any other classes. So this is actually not a circle. Not possible here. Not a circle. Because the radius can't be imaginary. Yes, ma'am.
Would it be like a different shape, or is it not a shape at all?
This one would not be a shape at all. There's nothing that we could actually graph from it. Good question. All right. Let's practice with another one where we really can do it. I did want to give you an example, though, where, like, if it comes out and we have a negative, that's not a circle, even though it appeared to be a circle from the original equation. All right. How do I want to start this? Add 15. Move my constant to the other side. I'm going to take this opportunity to reorder this so that I can group my x's and my y's easier. 2x squared minus 12x plus 2y squared plus 4y is equal to 15. Do I need to pull any coefficients out? Yes. What do I need to pull out? 2. It's the same on both of these. Did you guys notice when we were graphing the circles and we had to divide by the coefficient that they were both the same? And 2 example problems ago, when we had a coefficient that we had to pull out, they were both the same. The coefficients on the x squared and the y squared have to be the same all the time, or else it's not a circle, it's another shape. If they're different, it would actually be an ellipse, like an oval looking shape. They have to be the same in order for it to be a circle. All right, so to the best of my knowledge, right now we're focused on circles. If and when we get to ellipses, we will talk more in detail about those. All right, so when I get that 2 out in front, now I'm going to make room for what I'm going to add to make it a trinomial. So I have 2, and then y squared plus 2y plus whatever I need to make it a perfect square trinomial. And that is equal to 15 plus, I don't know, plus something else. With my x's, what am I going to have on that line? 9. So what do I add to the other side? 18. This is 2 times 9. And what about with the y's, what goes on the line? 1. So what goes on the other side of the equal sign? 2. So I have a 2 as my coefficient. How are my x's going to factor? X minus 3, whole thing squared, plus, what about the y's? Y plus 1, quantity squared. And what's that going to be equal to?
45.
Close. 35. Before I can identify my center and my radius, I need to make sure it's in standard form, which means I need to do what? Divide everybody by 2. Leave this as a fraction. Don't turn that into a decimal. If you turn it into a decimal over there, 35 divided by 2, if you write that down as 17.5, you're just going to create more work for yourself. So I would have x minus 3 squared plus y plus 1 squared equals 35 over 2. My center is where? Where is the center at? Sorry, where? 3, negative 1. And the radius, I would do the square root of what's after the equal sign, right? So I'm going to do the square root of 35 over 2. What's the problem? Square root on the bottom. Anytime I've got a fraction underneath the radical, I have to rationalize that denominator. How do I rationalize this? Multiply it by radical 2, top and bottom. So this is going to be the square root of 70 over 2. Does anybody have any questions about using completing the square to write these circles in standard form? Yes, sir.
Would it be plus or minus square root of 70 over 2?
No, because it's a radius, so we're talking about how far away it is. It's a distance which can only be positive. Good question. Normally when we introduce a square root, you're absolutely right, it's going to be a plus or minus. The only reason we don't have the minus is because from a geometric standpoint, I can't use that to calculate distance then. Yep. Yes, ma'am.
Would we have to, like, a point, like, will we just not put a radius, like, on a graph?
A radius like that. If it shows up on a homework, I'd pop it into my calculator and get a decimal approximation so that I would know how far to count in any direction. On a test or a quiz, I'm not going to ask you to approximate the square root of 70 and then divide it by 2. Yes. Do you guys have any other questions about completing the square to put a circle into standard form? All right. Let's practice writing equations of circles just given different features of those circles. So I want to write the equation for a circle that has a center at 2, negative 3, and a radius of 5. As a reminder, my equation, or my formula for the equation of circles, looks like this. And the center comes from H and K. So what's this going to look like inside the parentheses with X? X minus 2 squared plus y plus 3 squared equals 25. Why is it equal to 25? Yep, we're going to square this to get that part right there. Absolutely. So far, so good? On part B,
That's it.
yep, that's it. On part B, I know where the center is, but I don't know how big the radius is. I know my center is telling me H and K, right? So I can start writing this equation. What would it look like at the beginning? Inside the first set of parentheses. X plus 2, parentheses squared, plus, what do the y parentheses look like? Y minus 1 squared. That's equal to my radius squared. I don't know how big my radius is right now, but I can get it this far. And then they gave me this information about it passing through this point right here. In an ordered pair, what part comes first? And second? If I take this point right here and I substitute it in for x and for y, I can then evaluate it, simplify it to find r squared. So I'm going to put 3 in the place of the x. And I'm going to put 4 in the place of the y. And that will give me the r squared that I need to finish writing my equation. 3 plus 2, huh?
Feels a lot like Pythagorean theorem.
Mm-hmm. I've got 5 squared plus what? 3 squared. So that's 25 plus 9, which gives me what? It's going to be 30 something, right? 34. There's my r squared. I don't even need to know what r is necessarily because they just asked me to write the equation and I need r squared for the equation. So what would this finished equation look like?
X plus 2 squared plus y minus 1 squared equals 34.
Yep. X plus 2 squared plus y minus 1 squared is equal to 34. How we doing? Reasonably decent? Okay. Let's do a couple where we have to write it, given different pieces of information. I've got my center, -3, 6. This is my h and my k. So I can begin writing my equation. I know this would be x plus 3 squared plus y minus 6 squared. I just don't know what comes after the equal sign. That's why they gave me a little bit more information though, right? What more information did they give me? Tangent to the y-axis. What does tangent mean? Does anybody remember?
Oh, the opposite adjacent?
Super close. You're definitely thinking about it from a geometric perspective, which isn't wrong. In this case, what we mean by the word tangent is that it touches but does not cross. When you guys do those trigonometric functions, SOHCAHTOA, sine, cosine, tangent, that does have a relationship to this idea of tangent. But when you see it used in like a sentence, tangent means that it touches but does not cross it. So like, and specifically it touches in one point. Right now I am tangent to this little desk. I touch it in exactly one point. When I was sitting on it, that would not be. Yes, ma'am.
So it'd be like a point like 0, 3 or something.
Mm-hmm. So I need to use this information somehow to figure out what the r squared should be so that I can finish this. I got really confused the first time I ever saw a problem like this, trying to figure out how I could figure out the radius. So I sketched myself a little picture. Can I find where the center is on this picture? Yeah, I can go 1, 2, 3. Here's -3. And 1, 2, 3, 4, 5, 6. So approximately right here is my center. It is tangent to the y-axis, so it is going to touch but not cross my y-axis. So I see the y-axis here. How far over would I go until I was just touching it? 3 units. From right here to right here would be 3 units. How did you know that? How did you know it was going to be 3 units? H is -3. And so to get from there until I'm just touching the y-axis, I would have to move 3 units to the left, or 3 units to the right. So what is this 3 representing here then? What's that telling me? That's telling me my radius. I have the center marked, and it says that it's just touching, tangent to the y-axis. So however far I have to travel to touch the y-axis, that's our radius. So what should go after the equal sign? 9. Because that is 3 squared. I feel like we need to look at that idea a little bit more. Let's look at part D. On part D, it tells me nothing about the center, but what does it give me? It gives me the radius. The radius is 4. What else does it tell me? Center is in quadrant 2. All right, so I'm going to draw a quick XY axis so that I can see this. Here's quadrant 2. And I know the radius is equal to 4. And what else does it tell me? Touches both axes. More specifically, it just barely touches both axes. And I know the radius is 4. I know it has to end up somewhere in this quadrant. So if I start at the origin, I'm going to move a radius of 4 away, because that would put me 4 units away from the y-axis, right? Okay, so 1, 2, 3, 4. You guys agree that right here is 4 units away from my y-axis? So if I drew a circle right here, it would be tangent to my y-axis. It would just touch it, but it wouldn't be tangent to the x-axis yet, right? How do I need to move this so that it is 4 units away from my x-axis? Let's go up 4 units. 1, 2, 3, 4. If I put the center right here, is it just going to touch the x-axis? Is it just going to touch the y-axis? So here's my center at -4, 4. Do I have enough information now to write the equation for this circle? Yep, let's write it. What's it going to look like? X plus 4 squared. Y minus 4 squared equals 16. Because we square our radius. Beautiful. I want to look at one more with you guys. We're going to finish up semicircles on Monday. So you can do all of the homework except for anything about semicircles. I have the endpoints of a diameter. Tell me what you know about a diameter.
Twice the radius.
It's twice the radius. What does it have to go through in order to be a diameter? Has to go through the center. And because it's twice the radius, the center is also what of a diameter? Something that we learned about the other day. Midpoint. Do we know how to find the midpoint?
Yeah.
How do I find the midpoint of something?
X2 minus X1 divided by 2.
What does that say?
Minus 1 divided by 2.
Midpoint of diameter.
The one.
Oh, center. Yes, except we're adding them, not subtracting them. So we add our x's. So 4 plus -2, and then we cut it in half because I want the average between those. And then we do the same thing with our y's. So I would have 2 over 2 and 4 over 2. So where is the center for this circle? 1, 2. Did you find it?
No, I had said 4 instead of 2.
Oh, got it. I still need the radius. How am I going to figure out how big the radius is? Distance formula. Radius is equal to the distance between A and C. So let's do that. My radius would be equal to the square root. Here's where I subtract x2 minus x1. So I'm going to do 4 minus 1 squared plus y2, -3, minus y1, which is 2, squared. Well, 4 minus 1 is 3. This is going to be -5. So I have 9 plus 25. What's 9 plus 25? 34. So here's my radius. Do I have enough to write the equation for this circle now? Yes. X minus 1 squared plus y minus 2 squared equals what? 34. Everything on the homework except semicircles. Homework is due on Monday night, so we'll cover semicircles before then. You really need to start that homework and work on it over the weekend. There's no way you'll get it all done Monday night if you save it all for Monday night. Let me know if you guys have any questions.